Hi children, Dilip Bhatnagar here again. I hope you all have seen my earlier video, Integration by Parts Part 1, in which I explained the technique for integration by parts and solved a few basic problems. In this video, we will solve some advanced problems using the same technique. The first problem is I is equal to integral x cos inverse x divided by root of 1 minus x square dx. Now the formula for integration by parts is, I'll reproduce it here, integral u v dx is equal to u integral v dx minus integral du by dx integral v dx whole dx. Now we use the isolate technique for selecting the first function u. Yes, now I stands for the inverse trigonometric function. Since cos inverse x is an inverse trigonometric function, therefore we take u as cos inverse x and v as x divided by root of 1 minus x square. Therefore, I can rewrite I as integral, I'll write u first, cos inverse x into v is x, by root of 1 minus x square dx. This is my u and this is my v. Now applying the formula for integration by parts, I have I is equal to u, that is cos inverse x, so u integral v, so I'll get integral x by root of 1 minus x square dx minus integral du by dx, therefore d by dx of u, that is cos inverse x integral v dx of x by root of 1 minus x square dx whole dx. Right? Therefore, now let me take I1 as this portion as I1. This I'll take it as I1. Therefore, I1, let I1 is equal to integral x by root of 1 minus x square dx. Now I will use a substitution method to solve I1. So I will let 1 minus x square is equal to t Therefore, I have minus 2x dx is equal to dt. But since here I need x dx, I'll write here x dx is equal to minus dt by 2. Right? Now I'll rewrite this as therefore I1 is equal to minus 1 by 2 integral x dx is minus dt by 2, so dt I'll get here, and root of 1 minus x square is root of t. So I'll write t to the power of half here. Therefore, this is equal to minus 1 by 2 integral t to the power of minus half dt. So this will be equal to minus 1 by 2 t to the power of n plus 1 by n plus 1. So I'll get t to the power of half by half plus c. This will be equal to minus, this 2 will get cancelled, so I'll get minus root of 1 minus x square plus c. Right? So now I have solved I1 here. Now I'll rewrite for I. Therefore, I is equal to here cos inverse x and now I have integral x by root of 1 minus x square, that is my I1, that is I'll get minus root of 1 minus x square right minus integral d by dx of cos inverse x is minus 1 by root of 1 minus x square, and integral x by root of 1 minus x square is again minus root of 1 minus x square dx. Right? Now this and this will get cancelled, so I'll get I is equal to root of 1 minus x square cos inverse x minus 1 dx. This gives minus root of 1 minus x square cos inverse x minus integration of 1 dx is x plus c. So this is my first sum. Let's go to the next. Yes. Now, the next sum is I is equal to integral of x squared plus 1 into log x dx. Okay. Now, I'll reproduce a formula for integration by parts for the sake of convenience. So, integral u v dx is equal to u integral v dx minus integral du by dx integral v dx whole dx, right? Now, using the Eilate technique for selecting the first function, Eilate. Now, there's no inverse trigonometric function. Now, logarithmic, L stands for logarithmic, so log x will become u. Therefore, u is equal to log x and v will become x squared plus 1. Right? Therefore, rewriting I is equal to, now I'll use the formula for integration by parts, u integral v, therefore u is log x, so u integral v, that is x square plus 1 dx minus integral du by dx, therefore d by dx of u, that is log x, minus integral v dx, v is x squared plus 1 dx whole dx. Right? Therefore, this will be equal to log of x now integral of x square is x cubed by 3, integral of 1 is x, now minus integral of d by dx of log x is 1 by x, okay, not minus, okay, into integral of x square is x cubed by 3 plus x yes whole dx. Yes, this is equal to x cubed by 3 log x plus x log x minus integral, I'll get x squared by 3 plus 1 dx this will be equal to x cubed by 3 log x plus x log x minus, right, now this will give me minus 1 by 3, right, x cubed by 3 minus x plus constant c. So simplifying further, I'll get x cubed by 3 log x plus x log x minus 1 by 9 into x cubed minus x plus c. Right, children? Now let us go to the next problem. Right, now you'll find that there are some problems in which the integrand can be expressed as I is equal to integral e to the power of x into f of x plus f dash x whole dx, where f dash x is a differential of f of x. Now let us solve this to bring it into a standard form. Therefore I is equal to, now let me separate it, integral e to the power of x into f of x plus integral e to the power of x f dash x. Right, now let integral that I1 is equal to this portion e to the power of x f of x dx. Therefore, using integration by parts, I get, right, so using integration by parts, I have u is equal to f of x and v is equal to e to the power of x. Therefore, I1 is equal to u integral v, that is f of x integral v dx minus integration of du by dx. Du by dx is f dash x integral v dx, v is e to the power of x dx whole dx. Right, therefore this is equal to e to the power of f of x integral e to the power of x dx minus integral f dash x into e to the power of x dx. Right, now I'll put the value of I1 here. Therefore, I will be equal to I1 plus integral e to the power of x f dash x dx. Therefore, I have, now I'm putting the value of I, so I'll get f of x, I is equal f of x integral e to the power of x dx minus integral f dash x dot e to the power of x dx plus integral, yeah, this part, e to the power of x and f dash x x plus c. Therefore, this and this will get cancelled. So this will be equal to f of x integral e to the power of x dx, that is equal to f of x into e to the power of x plus c. Therefore, whenever you get a integrand in the form of integral e to the power of x f of x plus f dash x dx, that will be equal to f of x dot e of x plus c. Now let us solve some problems using this method. Right. Now here I have got I is equal to integral e to the power of x into sin x plus cos x dx. So here if I take sin x, f of x as sin x, then dy dx of sin x is equal to cos x. Therefore, here, since we know d by dx of sin x is equal to cos x, therefore I can be written in the form of integral e to the power of x f of x plus f dash x dx, where f of x is equal to sin x. Therefore, using this formula, I'll get I is equal to e to the power of x f of x, that is sin x, plus c. Right? Now, let us see another problem. Now, in this problem we have just a minute. Yes, I is equal to integral e to the power of x into 1 plus sin x divided by 1 plus cos x dx. Now, here we have I Here we'll use the formulas. Now we know that cos square A plus sine square A is equal to 1. Okay, we're going to use these formulas here. Next, we're going to use a formula sine 2A is equal to 2 sine A cos A, and another formula we're going to use is 1 plus cos 2A is equal to 2 cos square A, right? Therefore here I will rewrite as integral e to the power of x into, okay, now 1 I will write it as sine square x by 2 plus cos square x by 2. Okay, this is 1, and for sine x I write as 2 sine x by 2 cos of x by 2, right? And 1 plus cos x I can write as 2 cos square x by 2, right? So this will be equal to integral e to the power of x. Now this is if I see the numerator it is in the form of a square plus b square plus 2ab. So this is a plus b whole square. So I'll get sine x by 2 plus cos of x by 2, right, whole square, divided by 2 cos square x by 2 dx. Okay, so this will be equal to integral e to the power of x. Now I can write it as sine x by 2 plus cos x by 2 by cos, right, I can take this 1 by 2 outside, cos x by 2 whole square dx. This will be equal to 1 by 2 integral e to the power of x. Now sine x by 2 by cos x by 2 will become tan x by 2 yeah. And cos x by 2 by cos x by 2 is 1 whole square dx. This will be equal to 1 by 2 integral. Now I'll expand this, so I'll get 1 plus tan square x by 2 plus 2 tan x by 2 whole dx. This is equal to 1 by 2 integral e to the power of x. Now 1 plus tan square a is secant square a. So I'll get secant square x by 2 right, plus 2 tan x by 2 dx. Okay, that is equal to integral e to the power of x. Here I'll get 1 by 2 secant square x by 2 plus tan x by 2 dx. Now here, if I take f of x is equal to tan x by 2, that f of x is equal to tan x by 2, then f dash x is equal to secant square x by 2 into d by dx of x by 2. So that is equal to 1 by 2 secant square x by 2. So now this I is in the form of e to the power of x. This is f of x plus f dash x. So we have I is equal to e to the power of x, f of x, that is f of x is tan x by 2 plus c, right? Now let's go to the next sum. Yes, now the next sum is I is equal to x minus 3 divided by x minus 1 whole cube e to the power of x dx. So here again we will try to express this in the form I is equal to integral e to the power of x into f of x plus f dash x. So here I will get, right, I is equal to, now x minus 3 I'll write it as x minus 1 minus 2, okay, divided by x minus 1 whole cube dx, yeah, e to the power of x dx. So this will be equal to integral x minus 1 divided by x minus 1 whole cube, right, dx, okay, minus 2 by x minus 1 whole cube, right, e to the power of x dx. Now if I take let f of x x is equal to, right, now first let me cut this x minus 1, here it become whole square. Therefore this is equal to integral e to power of x into 1 by x minus 1 whole square minus 2 by x minus 1 whole cube dx. Okay, so here I'll take f of x as 1 by x minus 1 whole square. Therefore this is equal to x minus 1 whole to power of minus 2. Therefore f dash x is equal to nx to the power of n minus 1, that is n minus 2 x minus 1 whole cube, oh sorry, n minus 1, so minus 3. So I'll get this is equal to minus 2 divided by x minus 1 whole cube. Therefore I is in the form of integral e to the power of x into f of x, right, f of x is this, plus f dash x whole dx, right, where f of x is equal to 1 by x minus 1 whole square and f dash x is equal to minus 2 by x minus 1 whole cube, right. Therefore I is equal to e to the power of x f of x plus c, that is e to the power of x into f of x, that is 1 by x minus 1 whole square plus c. Thank you, folks. I hope you have found this class useful. In the next video, that is integration by parts part 3, we shall solve problems of the type integral root of x square minus a square dx, then integral root of x square plus a square dx, and integral root of a square minus x square dx using the same technique, that is the technique of integration by parts. Please like, share and subscribe to the channel to view more informative videos. You can press the bell icon to receive notifications whenever I post a new video. You can put your questions in the comment section below or email me at dlpbhatnagar@yahoo.co.in. Thank you, children.